Hello everybody, and welcome back to the building of this Cirrus Moth by David Boddington. We're now into 48 hours of solid rain, so there's nothing else for it but to get on with some building. So I'll tell you about what I've got done and what I'm going to tackle today on this dreek Sunday afternoon. Well, the first thing I've done is, as you can see, I'm focused on the engine bay. And what I've done is I've fuel-proofed the interior using a mixture of 30-minute epoxy and some methylated spirits. And if you add the methylated spirits once you've got the mix, it makes it fluid enough to paint with a brush. And I've painted the interior and it's had a good couple of coats of that, and I find that's a really good fuel-proof. I've also added some spruce to the sides because I anticipate that with the addition of the cowl on here up against this softish balsa, it would take a lot of knocks, so I thought it would be a little bit stronger by adding that. Plus I may be cutting away this aperture altogether, and then I would like to put an extra screw in here and in here to hold the cowl down in place, and that gives me something to screw onto. I've put some 1/64 ply on these areas before I epoxied it, just to toughen it all up a little bit. So that's done. I have to drill a hole in the bottom for the overflow tube that comes out of the bottom of the crankcase on this 4-stroke engine. It's a common feature in all of them to allow the excess oil to drain and fuel to drain out. That acts as a lubricant. So I'll need to put that in the bottom, and then that's done. So what's the focus today? Well, the focus today is I've long fancied putting on this model a pull-pull system, at least on the rudder, because I think the feature of having the cables running on the outside adds a lot to the appearance of the model. It's a bit more complicated with the elevator, so I'm not sure that I'm going to go there before. It's not something I've ever installed, so it is a little bit of a learning curve for me. So let's take a closer look. Here we are at the tail feather end, and as you can see, the horn for the rudder has been glued in. There's a slot into the upright and it dovetails in. It's made out of plywood, and the holes are in line with the hinge, which is obviously good practice no matter what method of control horns you're using. Now, having done a little bit of research and read up on the pull-pull system, the key to it is the distance between here and the hole has to match the distance between the fulcrum point and the connector for the servo end. So what we have here on this plywood, I've measured it carefully, and it's 25mm from the centre line to the hole that will hold the clevis. So let's look back at the business end. Now, this is by way of a mock-up, a trial of a sort of try-out of concept to see if it works. So what I did was I got one of these horns and I've added an extension onto it. That means that from the centre line, the pivot line on the boss to the outer hole, it's 25mm, therefore matching the one on the rudder. And I then had to think about how I was going to rig it up. So let's have a look inside. Oh, well, before we do that, you can see that I've cut an aperture out here, a slot, which would have a cover over it, which would be narrower. That's further down the line after it's been covered. But let's flick it over and have a look at what it will look like inside. Here we are on the underside, and I've placed in the bearers. They haven't been glued in. the bearers for the servos here, I've also made an additional plate to go across the interior, which will be the mounting point for the control horns, the cranks. Now, as it is with the one that I've just shown you, the 90-degree angle, it would mean, if I drop this servo in, you'll get an idea of how it would work. The servo would have to be mounted internally, like that. Then obviously you'll have two cranks, one on this side and one on that side, with a bar going between the two, and then the servo arm at right angles would go in the outer horn, so that when that moved, it pulled the cranks on both sides. The problem with this setup is that because it's a 90-degree crank, the amount of throw you can achieve is limited by how far this part of the right angle can go before it fouls the side. So I've had to think of an alternative to this. I'll show you what I'm going to do in a second, but if I take that out, what I did was I didn't even go to the trouble of doing both cranks, because I wanted to see how the pull would work. So we'll flick it over again. You'll be going dizzy here. I'll flick it over again and you can see how it works. I hope you can now see how this would work. So the crossbeam, that's also not glued in, so this would have to be centralised. This has a cover plate over the top of it to make a narrow slot just wide enough for the crank itself, or the lever itself. These are commercial fittings which actually came from with the kit, but you can buy, they're readily available. You have a brass insert into the clevis, and there's a lock nut which is important to stop it unwinding and affecting the tension of the line. I've only put some thread in here. This would be wire cable or fishing trace. So that goes to that end, and remember, from the fulcrum point to this point here, it's 25mm. I achieved that by sort of, as I said, or I hope I showed you, gluing one piece onto another piece. It was only a temporary measure, and I'll explain what I'm going to do instead. And then if we pan down to the other end, you can see that the cable would run down the outside of the fuselage to the rudder, and if I move the arm, you can see that the rudder moves across effectively. I think that looks really neat, but I need to make a different crank, and what I'm proposing to do is, instead of having a right angle, if I have a straight through bar, I can mount the servo behind, have a V, two separate arms coming to that point, and then I can get more through without this fouling on the side. I hope it becomes clearer when I do it. And to do that, I'm going to have to make them, because I haven't been able to find anything that would fit the bill other than having to go at making it myself. So this is what I'm going to use. This is blank circuit board. It's a fiberglass boarding with a copper coating on both sides. It's double-sided, and that's great because you can solder directly to it. What I intend doing is cutting out the lever with the whole 25mm from a fulcrum point. From a fulcrum point, and then having an arm coming out to allow me to attach the servo connectors to actually operate the cranking mechanism. But to do that, I'm going to have to machine a couple of bosses for the centre. Let's get cracking with that then. hope you got the gist of what I was doing there. It's not very easy in the workshop. It's very much a one-man space and it's difficult to set up to video. But I've now made the boss and the little disc that'll go on the top to space it, and along with the washer that will allow me to get, and the thickness of that plate, that'll allow me to get a friction-free movement on the fulcrum point. So now all I have to do is to mark on here what I want, drill it out, solder the boss to it, and then install it and see how it looks. So let's get cracking with that then. The holes have now been drilled out for the boss and for the coupling. So what I'm going to do now is I'll push them through the other side, solder them, well, I'll cut them out actually, then I'll solder them in place, and then we're ready to try them out and see how they look. Let's crack on. Now there's the blank, shall we say, cut out. I've actually used a little tool here, and I call it a scroker. If you look at the end, it actually removes material when you draw it towards you. It's great for cutting plastic card without leaving that plough effect where the material gets pushed out of the way rather than removed. I believe back in the day, engineers used to grind them out of old hacksaw blades and use them for marking off jobs into metal. So that's basically it. If I actually put the central boss in, I'm going to solder that on in a moment, and then I'll clean everything up, and that's the first. Well, you can see how it'll work, only this will be soldered, obviously. I'm going to actually, actually it needs to be soldered to the other piece, doesn't it? That would have been silly. So it gets soldered onto that, onto the boss, and then the whole thing can swivel. So I'll clean this up, get it prepped, we'll get the soldering iron on and we'll solder this up. The soldering iron's heated up now. And what I'm going to endeavour to do is to solder this boss through the actual plate. Now what I need to do is line it up first to make sure that it's accurate. I don't want to leave the drill in there because I'll end up soldering it. Obviously, that's what's going to happen, isn't it? But what I could do is get it lined up, and I'll use this wooden clamp in the form of a clothes peg to ensure that I can hold it, and now I can run some solder around there without burning my fingers off, but I know it's lined up. Let's have a go. I'm putting some solder onto the soldering iron. Seems to have held there. Let's see if we can get some round here. That weather's horrendous outside. I think we've all had enough of it. Right, I'm going to let that cool down. And then hopefully the boss will still pass through, or the pivot point will pass through there. See how it goes, and I'll clean all this up. There's the arm soldered up. Let's see if this will pass through. This is the proof. There you go. I never doubted myself. So all I need to do is tidy that up, drill a couple of holes in here, or 3 or 4 actually, to give me choices for the sensitivity from the servo, and then that can be cleaned up and replace the plastic arm that I had before, which was a bit of a mess. I would have had to put screws through here, and there would always been the risk of it coming apart. It was too thick, and also the right angle meant that I couldn't get the leverage I wanted on it. So that's a much better solution, I think. So it's just a case of tidying that up now. As I hope you can see now, the servo's in the position that it needs to be in. I've put on the cross piece, the horn, the arm, and I've pushed it down so that it right angles to the actual body of the servo. If it isn't, you simply move it round another tooth, another leg, and then you cut off the ones that you don't want. So that'll be in the centre. This has now been prepped, and I know the position I would like to put that in, because on the previous one where I used this plastic horn, and that's where I came across the problem with this fouling because it was at right angles, I tried a couple of positions. I wanted to take it just a smidgen further out, but I couldn't for the reasons outlined before this fouling the side basically. So now that I can take it out another 3 or 4 millimeters, I'm going to do so, and that'll mean that the cable doesn't rub against the side of the fuselage when it's all set up. So all I need to do now really is get this drilled out, get the horns put in place, and when I'm happy with everything, I'll glue them in place and we'll connect the cables up, although they'll obviously have to come off when it comes to the covering because they would only get in the way, but I want to try it out at least. One little tip before I go and do the next part: if you've got a straight piece like this that you need to push tight up against the sides, it's difficult to get it in to achieve that. And one of the things I do is I simply round one corner and then round the opposite corner. And when I put it in, I rotate it in that direction, clockwise, and you'll manage to get it round because of the relieving of the corners, but you'll maintain a nice tight fit. Job's almost done. The bearer that holds this servo and will hold other servos, or at least one more, and this crossbeam that holds the cranks hasn't been glued in yet. I simply wanted to have the flexibility of moving things around, but as you can see, that's the desired effect I was after. It's friction free. I'm sure that's going to work really well. Next thing to do is to try just rigging it up temporarily to the rudder and see how it seems to work. Well, I've rigged things up with some cotton actually. Of course, when it comes to the final installation, after everything's been covered, that'll be done with trace fishing wire, crimped, and there will also be adjustments at either end. So I will be actually able to adjust things, but here goes. Really pleased with that. I think it looks really cool. Seems to do the job. Yep, that would do for me. Right, thanks for watching. If you've enjoyed it, please give it a thumbs up. If you haven't already subscribed, please consider doing so, because you'll be able to enjoy the rest of the journey. And it's really useful when it's a rainy day like we have here. At least you get a little bit of a modelling fix. So bye for now, take care, keep building, keep being creative. Bye now.